The James Webb Space Telescope, JWST, is the best telescope we have for space research right now. It's meant to help us figure out stuff like our solar system, planets around other stars, and how the universe is put together, so we can understand our place in it all. Recently, scientists aimed the JWST at a star 120 light-years away. They found some good signs of carbon stuff in the air of a planet that might be covered in oceans. That's pretty wild for researchers. How'd they get such a cool result? This find gives us an amazing look at a planet outside our solar system, and it makes us wonder about whether there are other planets out there that could have life. Let's check out this planet find and the cool details it shows us. If you want to keep up with the latest space stuff and what's happening in the cosmos, subscribe to our channel, like this video, share it, and turn on notifications so you don't miss anything. NASA's James Webb Space Telescope recently made a discovery about the exoplanet K2-18b, a planet way out there that's about 8.6 times bigger than Earth. What's really exciting is that they found carbon gases like methane and carbon dioxide in its atmosphere. This backs up earlier research that said K2-18b might have what it takes for life. It seems to have an atmosphere full of hydrogen and maybe an ocean on its surface. The Hubble Space Telescope first looked at this exoplanet's atmosphere to see if it could support life, which really helped us learn a lot about this planet. K2-18b is about 120 light-years away in the Leo constellation, going around a dwarf star called K2-18. Planets that are between the size of Earth and Neptune, often called sub-Neptunes, are rare in our solar system because we don't have any like that here. The thought that K2-18b might have a lot of carbon and a hydrogen-filled atmosphere has astronomers really interested. A lot of them think these kinds of planets could be the best places to look for life. Finding methane and carbon dioxide, but not ammonia, makes the idea that this planet has an ocean under its hydrogen skies even better. Early studies even hinted that there might be dimethyl sulfide, a molecule on Earth made by marine plankton. But we're not sure yet if it's actually there on K2-18b, and we need to check it out more. The JWST is still looking to see if dimethyl sulfide is really in the planet's atmosphere in large amounts. According to a researcher at the University of Cambridge, just because K2-18b is in a place where there could be liquid water and it has carbon doesn't mean it can have life. Since the planet is 2.6 times bigger than Earth, it's likely covered in a thick, icy layer with high pressure, kind of like Neptune, with a thinner atmosphere full of hydrogen and a surface that might have oceans. Even if there's liquid water, those oceans might be too extreme, with too much pressure or weird chemicals, to support life as we know it. Still, scientists now have the most detailed look at the atmosphere of any sub-Neptune planet in a place where it could have life, which lets them figure out what chemicals are there. A member of the Cardiff University team said that they figured out how to watch starlight pass through the exoplanet's atmosphere as it moved across its star. K2-18b is a transiting exoplanet, which means it dims the light of its star a little when it passes in front of it. That's how NASA's K2 mission found it in the first place. When this happens, some of the starlight goes through the planet's atmosphere before it gets to Earth. Telescopes like JWST can look at the marks the atmosphere leaves on the light to see what gases are there. The researchers want to keep watching with JWST's mid-infrared tools to check the atmosphere and find out more about the weather on K2-18b. Their goal is to find signs of life on planets that could have it, which could change how we think about life in the universe. Also, the JWST has made other cool finds. Astronomers used it to spot complex, organic molecules, kind of like smog or soot, in a galaxy far away. This is the earliest we've ever seen these compounds in space. That seems both amazing and a little scary. These finds from far out in space are changing what we know about the universe. The molecules, called aromatic hydrocarbons, were in a galaxy that started forming when the universe was only about 10% of its current age. These carbon compounds, which we find in petroleum and coal on Earth and which cause air pollution, are big and complex, with dozens or hundreds of atoms. What's amazing is that these molecules showed up relatively soon after the Big Bang, which we didn't expect. To put it in perspective, the light we're seeing from that early galaxy started its trip about 1.5 billion years after the Big Bang. Since the universe is now about 13.8 billion years old, we're seeing it in one of its earliest stages. Even more amazing is that the Webb telescope helped us see this and will let us keep making similar finds, going back about another billion years into the past. If we could look even further back, would we find even more of these molecules closer to the beginning of the universe? This makes us wonder about our ideas about the cosmos. Before, astronomers had only confirmed that these organic compounds were in the early universe. But with JWST's better vision, we can now see exactly where they are. It's also weird that these compounds are spread unevenly in the ancient galaxy SP41847. What's especially cool is that this galaxy already had about the same mass as the Milky Way and made about the same amount of carbon and oxygen, even though it was only a tenth of its current age. As we keep exploring into the unknown, driven by curiosity and science, we're still amazed by how big and complex the universe is. Every new thing we find brings us closer to figuring out the mysteries among the stars. As our space research gets better, it's only a matter of time before the cosmos shows us even more of its secrets, helping us understand our place in it. As we learn more about space, the James Webb Space Telescope keeps giving us new information. It's changing how we see distant planets and galaxies, pushing the limits of what we know about the cosmos. This awesome telescope lets us look deeper into space than ever before, showing us puzzles that scientists before us couldn't solve. Finding complex organic molecules in ancient galaxies is just one example of how JWST is helping us understand the early universe and how it has changed over time. One of the most interesting things about these finds is that they suggest that life, or at least the stuff that makes it up, might be in places we thought were too harsh. The fact that there are carbon compounds in the atmospheres of planets like K2-18b opens up new ways to look for signs of life on planets that might be like Earth. These compounds, like methane and carbon dioxide, are often related to living things on our planet. Finding them on distant planets doesn't prove there's life, but it makes us want to look harder to see if life could exist there. Future NASA missions will focus even more on this possibility. JWST's ability to analyze exoplanet atmospheres is a big step forward. It lets scientists not only find basic elements but also spot complex chemical signals that might point to life. This level of detail is important for figuring out if distant planets could really be habitable. As we learn more, we get better at spotting subtle signs of life, whether it's through gases in the atmosphere, organic compounds, or other things that show biology. Besides exoplanets, JWST is giving us great information about how galaxies form and change. By watching ancient galaxies, astronomers can track how stars form, how elements are spread out, and what forces shape groups of stars over billions of years. This is important for understanding the history of our own galaxy, the Milky Way. The discovery of aromatic hydrocarbons in a galaxy that formed much earlier than ours shows just how much we're learning about the early universe. As we keep pushing into space, every new thing we find brings us closer to answering some of the biggest questions humans have. Are we alone in the universe? How did life start? What will happen to the universe in the end? These questions have fascinated scientists, thinkers, and dreamers for a long time. Now, with tools like the James Webb Space Telescope, we're better equipped than ever to look for those answers. Each discovery widens our view and takes us one step closer to finding the truths that are out there among the stars. According to a researcher at the University of Cambridge, even though K2-18b is in a spot where liquid water could exist and has carbon compounds, it doesn't automatically mean there's life there. Since the planet's about 2.6 times bigger than Earth, it might be covered by a thick icy layer with a lot of pressure, kind of like Neptune, with a thinner hydrogen-filled atmosphere and a surface that might have oceans. Even if there's liquid water there, it might be too extreme, which means too much pressure or the wrong chemicals to support life as we know it. Still, scientists now have the most detailed look at the atmosphere of any sub-Neptune planet in a habitable zone, which let them figure out exactly what chemicals are in there. A member of the Cardiff University team said that they got around the challenge of observing this by watching how the starlight went through the exoplanet's atmosphere as it passed in front of its star. K2-18b is a transiting exoplanet, so when it passes in front of its star, it dims the light a little bit, which is how NASA's K2 mission first found it. As this happens, some of the starlight passes through the planet's atmosphere before it gets to Earth. Telescopes like JWST can study the fingerprints the atmosphere leaves on the light to see what gases are there. The researchers are going to keep watching with JWST to confirm what's in the atmosphere and learn even more about K2-18b's weather. What they are trying to do long-term is find biomarkers on worlds that could have life, something that could change how we see life in the universe. Also, JWST has made some other cool finds. Astronomers have used it to find complex organic molecules that are similar to smog in a galaxy that's far away. This is the earliest we've seen these kinds of compounds in space. To me, that's both awesome and a little scary. These finds from deep space are changing how we understand things. The molecules they found, aromatic hydrocarbons, which are in a galaxy that started forming when the universe was really young, only about 10% of its current age. These carbon-filled compounds, which you can find in petroleum and coal on Earth, and which add to air pollution here, are big and complex, made of dozens or hundreds of atoms. What's wild is that molecules this complex showed up pretty soon after the Big Bang, which goes against what we thought. To put it in context, the light that's reaching us now from that ancient galaxy started its trip about 1.5 billion years after the Big Bang. Since the universe is around 13.8 billion years old now, we're seeing one of its first stages. Even wilder is that the Webb telescope made this find happen and will let us keep finding things like it going back another billion years or so in cosmic time. If we could look back even further, would we find even more of these molecules closer to the start of the universe? This makes us think about our models of the universe. Before, astronomers had only confirmed that these organic compounds were in the early universe. But because JWST is so clear, we can now see exactly where these molecules are. And, the compounds are not evenly spread out in the ancient galaxy SP41847, which is weird. What's really cool is that this galaxy had already gotten to be about the size of the Milky Way and made about the same amount of carbon and oxygen, even though it was only a tenth of its current age. As we keep exploring, driven by curiosity and science, we're still blown away by how huge and complex the universe is. Every new find gets us closer to figuring out the mysteries out there. As our space research gets better, it's only a matter of time before the cosmos shows us even more of its secrets and helps us understand where we fit in. As our knowledge grows, the James Webb Space Telescope keeps giving us awesome insights. Its observations are changing how we see distant worlds, pushing our understanding of the universe. This incredible telescope lets us look deeper into space than ever before, showing us mysteries that scientists before us could not see. Finding complex organic molecules in ancient galaxies is just one example of how JWST is helping us get a handle on the early universe and how it's changed over time. One of the most exciting things about these finds is the suggestion that life, or at least the stuff that makes it up, might be in places we used to think were impossible. The carbon-filled compounds in the atmospheres of planets like K2-18b opens up cool new ways to look for signs of life on planets that might be similar to Earth. These compounds like methane and carbon dioxide are often tied to biological processes on our planet. Finding them on other planets doesn't prove there's life, but it makes us want to look closer and see if life could be there. Future NASA missions will focus on this possibility even more. JWST is super precise and analyzing exoplanet atmospheres, which is a huge step forward. It lets scientists not only find basic elements but also spot complex chemical signals that might point to biological activity. This is really important for figuring out if planets far away could actually be habitable. As we learn more, we are better able to catch subtle signs of life, whether it's through gases in the atmosphere, organic compounds, or other things that tell us life might be present. Besides exoplanets, JWST is giving us super valuable info about how galaxies form and grow. By looking at ancient galaxies, astronomers can track patterns of star formation, how elements are spread out, and the cosmic forces that shape groups of stars over billions of years. This is important for understanding the history of our own galaxy, the Milky Way. Finding aromatic hydrocarbons in a galaxy that formed way earlier than ours shows just how much we're learning about the universe's early stages. As we keep reaching out into space, every new bit of info brings us closer to answering some of the biggest questions we have. Are we alone in the universe? How did life start? What's going to happen to the universe in the end? These questions have been on the minds of scientists, thinkers, and dreamers for ages. Now, with tools like the James Webb Space Telescope, we have a better chance now than ever before of finding those answers. Every discovery we make broadens our view and takes us one step closer to seeing the truths that are beyond our stars.